So good morning, guys. The session has started. So please do join as soon as possible. Make sure your friends also know that the session has started. Just try to contact them and let them know that the session has started, and try to make them also join. Good morning. Good morning. Good morning. Try to join quickly, guys. From the next session, please try to join quickly.
Good morning, guys. Good morning, everyone. I hope you are doing well. Am I audible? Just confirm that am I audible? So I'll start the session in 2 more minutes. Okay, just a minute. We'll start the session. So I hope you have all finished. You're trying to finishing all the labs. So what are the labs we are assigned? Just finish the labs. Okay, as soon as possible, finish the labs. So already I shared what are the 3 labs you need to finish. I hope you received the credits and try to finish the labs. Just give me a minute. I'll just. Okay, guys. Just I talked the team. Just will inform you. Okay, so I'll just a minute. I'll create on. Guys, just I created about the credits one poll. Just who have received and who haven't received. Just poll that. Vote there once. So you'll get to know how many numbers haven't received. Guys, am I clear? Just I created a pool. Just who haven't received the credit, just poll that vote there. So we'll get to know. No, the 35 credits is not enough. Just you're going to get the access from Google Teams, remaining 2 labs. Okay. For beginner, it's fine, but coming to the intermediate and advanced level, you need at least minimum credits. Okay. So which lab you are facing this issue? Aditya Raj. So on which lab you are facing this error? So I think you have a group, right? Telegram group, so you can post it there. So first lab, okay, they are updating first lab, I think so. Just do one thing, Aditya. Just go to in the top right corner, you will find the question mark symbol, help section. So go there and just raise a mail there. Okay. So they'll clarify your all doubts. Okay. It's like they're going to verify and they'll give you the access. Just talk to a team about the credits. Just they will check and they'll update. Okay, don't worry. Okay, today we are going to discuss some more interesting things. So in this session, we are going to learn how this generative AI is going to work. Okay, I'll show first that how this generative AI going to generate the images. Okay, already we discussed about GANs, right? Yes or no, guys? What is the full form of GAN? Anyone? Just let me know. What is the full form of the GAN? Yeah. Okay, I'll discuss just. I inform the team about the thing of about credits. Okay, don't worry. I'll inform you. Okay. In this session, we'll discuss about how to these generative AI going to generate the things. Okay, we'll discuss that. Just a minute. I'll share my screen. Guys, are you able to see the screen? Is it visible? Okay. So just we'll discuss in this session how this generative AI. In the last session, we discussed about GANs, right? So we'll discuss in this session how this generative AI is going to work. Okay. So how we can generally we have said that one we are going to have the generator, other one we are going to have the discriminator. So we'll see that how this generative AI and the discriminator is going to work. Okay. So for that, I'm just installing required libraries, guys. Okay, I'm just installing required libraries. So I'm just installing NumPy. So as NP, what it will do here means as NP is nothing but just it is going to act like as a nickname. So how the generally human going to have the nickname, so they're going to call with that, right? So in the same way, we are going to have the name for act as NP. So which is act like as NP. We are not going to use every time NumPy and NumPy. So the use you can use as NP. Okay. Using this TensorFlow as TF. Okay. Next. Float. So flow. I'm using Keras. Okay. What it will do, we'll discuss. Okay, guys. Don't worry. Just a minute. I need to change the shape. So these are the different layers, guys. Okay. I can use this ReLU function. So what this ReLU will do means, so these are the different layers. Layers dot. Okay. TensorFlow. Sequential. So but no need of this. Input bias. Sorry guys, I just don't know if it I didn't see that, so sorry for that. Didn't check that. Okay, just revise this. Okay, is this clear with the importing libraries? I hope that the thing is clear with importing libraries. And just what I'm just doing, I'm just here, I'm getting my data set, guys. Okay, just here I'm getting my data set. So what this data set generally will do means, so in TensorFlow from Keras, so we imported one more module, that is Keras. So in TensorFlow we have Keras. In that we're going to have the data set. So already in this Keras there is a lot of libraries. So from that I'm just I'm just using data sets, one of the module, and in that, from that module I'm just importing Minis data set. That data set is going to have the numbers. So in the previous, just I said no, in that so what type of error you're getting? So try to import first. What are the libraries you're just doing? Just import first. And one thing, while importing, just you need to install pip install. So have you installed? So try that. Pip install TensorFlow, pip install Keras first. So no, not importing. First you need to install. So you need to install like this. If you want to overcome this error, just you need to install pip install. Okay, install TensorFlow. So like this, you need to install each and every library like TensorFlow, Keras. Okay, then you're going to get NumPy, pip install TensorFlow, pip install Matplotlib. So you need to install every library. Then you're going to get overcome. You can overcome it. Okay, make sure for that first. Okay. So see, if I run this, it is going to say that already satisfied. See, requirement already satisfied means already I had. So you need to install. Okay, that thing. Okay, so these are libraries I'm just installed in my backend, and after that, what I'm doing, that I'm just getting my data. So getting my data from TensorFlow as from Keras. So dataset minis load data. So this is a place where I'm getting my data. Okay, where I'm just getting my data. So here I'm just I need only the data of X-train. X-train is nothing but, so in this, how these images are generally is going to locate means, so it's going to have the numbers, okay, numbers, whereas your friends is going to write in different style. If I ask your friends to write a 0 to 9, so he's going to write in one format. If I give to you to write 0 to 9 numbers, so then you're going to have your different handwriting style, and you're going to write in other format. So everyone is going to have the different style. So they have collected like this nearly 70,000 images, and they made this data set. So from that, I'm just accessing only images. I'm just not specifying this is 0 image, this is 1 image. If the image carry the 2, I'm not specifying this is a 2 image. Like this, I'm not specifying any class. Okay, that's why I just removed the white test and white train values. Okay, just I'm going to get only the images. I'm not going to get name of the images like labels. Okay, I'm not going to get. After that, what I will do, I just got the numbers. So I just gave the previous example, right? So this is my example. So these are my numbers which is going to have in my images. Okay, images, I'm just, these are the numbers because the images going to carry the pixels. Okay, images going to have the pixels. In that, each and every pixel we are going to have one number. So it is going to from 0 to 255, guys. So this is because, so every image is going to carry some pixels. Each pixel is going to carry some colors, right? So for every color, they're going to have the number. So that numbers is between this one, okay, 0 to 255. And after that, what it will, for example, I had a number. So I had a pixels like this. So 230, 210, 50, 34, 36. So like this, if I have only these numbers, so what happens? If I only have this type of numbers, so if I want to do any calculation with any huge number, if I want to calculate with this huge number, because we are going to perform operations, no, at that time, if I want to do, I'm going to get huge number like this, right? So if I want to perform again one more operation like this. So what happens? It's going to have yeah. So this is the thing is going to happen. If I want to multiply, I'm going to get the huge number. So like this, if I want to perform for every number, it is going to huge, it will take huge computation cost, right? So you need extra CPUs and you need more storage. So to overcome that, what we will do means just I'm just making all these numbers into one scale. Scale is nothing but just a range of numbers. So in the previous we had 0 to 255, right? So I'm just converting all the numbers in the range of -1 to 1. Why? Because this number will give the accurate result. So it's not going to become more computation. So if the number is like this, for example, just I've converted into -1 to 1. So the number is going to look like this, like 0.5, and the next number is 0.2, or else the next number is 0.4. So like this, I'm going to have the each number between -1 to +1. So if I perform the operation the same as previous one, if I perform that like this with the number, it is we are going to get the only the small number, right? So like this, we can reduce the computational, but we'll get the same result, guys. Okay. So this is the thing why I'm just using. So this one has type of np.float32. Float32 is nothing but the value which is going to have the range. So for example, if I have the CPU, based on the CPU, it is going to consider. So based on that, numbers is going to be evaluated. And this 127 is nothing but just off of the 255, you're going to get the value. Just I'm dividing with this, then I'm going to get the range between it, both of this. Okay. And next, I'm just getting dimensions. So is that am I just expanding my dimensions? Okay. I'm just expanding my dimensions. Please check that have you loaded the data set or not if you are getting error. So that is the thing is going to happen. Okay. I'm just moving forward. So I'm just taking one variable, guys. I'm just taking one variable. That name I'll just name it as. I'll just name it as. Let me write it as in caps. Okay, it will help me. Okay. For error. Okay. Buffer size I'll specify. Okay. This is my variable. I think you know, right? What is variable, right, guys? So and buffer size and batch size. So what is buffer size and batch size? You will get to know. I'll just take it 128. So what this buffer size and batch size you will get to know. Okay. So I'm just what I'll do. I'll just make it as my data set. So now my data set is going to be ready. I'm using TensorFlow dot data set from tensors slices. Okay. So this is how it is going to work. So I'm just using this. So what happens here? So what is happening here means, just let me explain this. See, I already said that this data set is going to carry views 70,000, but I'm just taking only 60,000 images. Okay, I'm just considering this 60,000 images, and these batch size is nothing but the batch size is nothing but these 60,000 is images is going to divide into 128. Means each batch is going to carry 128 images. Okay, just divided the 60,000 into, so for single batch it going to it need to carry 128 images. It's better for me. Okay, so that is the reason I just took. So why I just divided means I'm just shuffling the data. So how this data generally is going to have means, for example, this is class 1, so the name of the class 1 is 1. So now I'm going to have only all 1 numbers, just I already told now. So the numbers is going to have the 0 to 9. So in this 0 to 9, your friend will write 1, you will also write 1, and remaining other persons also will going to write 1. So all the ones will going to have, all 1 images going to have in this class. Okay, so that is the thing. So it's going to have continuous like this. If next class, if it is 2, then in the class 2 it is going to have all the 2 images. So this is a thing. If I pass the same things to the model may not give the good results. So for that, what I'll do, I'll just shuffle the data. I'll just use, you can see here, I just use shuffle. Okay, I'm just shuffling my data. Okay, so using by this shuffling, so I'll get the good results. Okay, so the model will not going to apply any copy paste item. So that is the thing, I'm just using that. Okay, just let me run this. See, too many values are unpacked. Okay, just let me solve this. Just let me check this. Okay, I need to specify the here one more underscore. Okay, because here X train and X test and Y train and Y test, I'm just skipping the X train and X test. That's it. So now you can see that. Okay, and next I'm just check with that. I'm just now, so till now we just, I'm just loaded my data set. Now my data set is ready. So now my data set is ready. So I'm not going to do any changes. This is my data set. Just I compressed the data and expanded the dimensions, as well as I shuffled data, and just took a one up variable and just I just put there all the numbers. Okay, all the data, all the images. Okay. Now what I will do? Now what I will do? I'll just build a generator. Not just I will build a generator. How I'm going to build this generator? So I'm just using one function that is building generator. Okay, I'm going to specify, just see it is suggesting me that I'm not going to use that. I'm just going to use build generator. Okay, suggesting me that to build generator. Okay, I'll go to my home. Okay. Okay, generator. So this is my function, guys. I think you know what is meant by def, right? So the model equals to, I'm going to use sequential model. Okay, sequential. I said no, the sequential will help that to go one by one, right? So input size and shape is this, and I'm not going to use this bias right now. I don't need. And just coming to this, I'm just going to use 256 is fine. No need of the number. Okay. So this is my layer, guys. So what is this dense layer will do? Means this generator. So we are going to pass a noisy data. I already said that in explaining before that generator will take noisy data. Noisy data means the data is going to look like this. Just let me show that with that. So like this row, single row. Okay. Like this, it is going to carry 100 to 200 numbers. Okay. So using these single row numbers, we can form an image. Yes, but we need one layer that we called it as a dense layer. Dense layer will help that to reconstruct. It will shape the data. So we are passing the 100. So we just said that input shape will going to get the 100. Okay. And next, just we are adding the layer. Okay. Just I can specify like this also. I will do one thing. Just a minute. I'll take as a list, so I can carry complete all the things. I'll just remove add. So no need. You can do this both. Like every time you need to add model. So without adding model, just you can do this. So it will carry here, and no need to add every time model add model add. Just again. Otherwise, we need to add every time. So model add like this. So I'm just taking leaky relu and specifying this is a number I need to get. So what the leaky relu will discuss. Okay. About that. Coming to the next, I need to check is this everything is correct. Let me go back. So I'm just removing this. It will help that doing dense layer to 56. Input shape is 100. Okay. Next, we can read here, guys. Okay. So no need of this also. Okay. Okay. Because we are not specifying add. Okay. So for that reason, so I'm just removing that. So this is how it is going to work. Okay. Now, so I'm using a key relu. I'll explain. Okay. Just a minute. I'm going to write one more dense layer. Yeah. So it is showing that write this dense layer. Okay. Now here I'm just going to specify this. So I can do in the two methods, right? So I can do 28 into 28. So I can use that, or else I can use 784. So what is this 784? Why I need to use this? See, I use two things, right? 128 into 128 and this. So why I'm using this 128 into 128 means, sorry, 28 into 28. So these are all the neurons, guys. Neurons is nothing but, so it is going to be going to have no, so we are going to apply some filters on that to extract the information from the image, and we'll start slowly constructing. So like first we'll start the image size into 2 into 10. Okay, 2 into 2. Just we are going to use 2 into 2. After that, the model will reshape and it will update for 4 into 4. Means I'm just it going to say that every time the model is upsampling the images. Every time the model is upsampling the images. So that is the thing. Just we are using this shape. Okay, dense layer. So this is a 512 is nothing but filters which will help that model to understand. Okay. And coming to the next, why I'm using 28 means I already said, right? Generator, what it will do, it will generate a new image, right? The model will generate the new image. So while generating, if it is, for example, the image size we took here is a 28 into 28. Why means these data set images are in the 28 into 28. So if the model generator we use 32 into 32, what happens? Because the discriminator had the image size is 28 into 28, but we are generating 32 into 32 image, then there is going to have the mismatch. Then finally the model will go into the loop, right? So it will every time generator will generate, discriminator will reject that. This process will go on. So to overcome that, so we need to specify the last layer with the size of the actual size of the image. Okay, then we will get the accurate result. Okay. Coming to the leaky ReLU, what this leaky ReLU will means, the leaky layer is nothing but it is like activation function. It is one of the activation function which will help the model to learn some complexity. So while calculating, what it will do means it will multiply some numbers and it is going to rectify the things. Like what happens, for example, there is a neuron. Okay, there is a neuron. So it is already doing some calculation, but it haven't learned something. So what this ReLU will do means it will check that what are the output we'll get from that neuron. So generally the neuron is going to give the output, right? So using that output, if it is a negative value, then this ReLU, what not we are not talking about leaky ReLU, just I'm explaining about ReLU. So what this ReLU will do means it will just if it is a negative value, for example, the neuron output gave the negative value like minus 72. So what it ReLU will do means, so it is going to act like this. So this is my ReLU function, for example. This is my ReLU. So what happens if it is a value? For example, I'm just taking the my x. Okay, how I'm just explaining x. So my x equals to minus 20. So this is my value. Just I got from neuron output. I got from neuron. So I'll pass to that layer to the ReLU. I'll just pass. So I'll just what happened in ReLU? It will take 0 and it will take x. Okay. So if the value was negative value, then it will give the ReLU will give the output for me as 0. Okay. It will use max. Okay, don't worry. So it will give the 0. Okay. If it is the value was negative value, so I mean positive value, then it is going to give the value of same. Okay, so what happens means, if it is the negative value, the neuron is going to be deactivated because we'll get the 0. So with the 0, you will multiply with the other numbers, also you're going to get the 0. So that is the thing, the neuron is going to be deactivated there itself. So whereas this leaky ReLU will not give, if it is a negative value, if it is negative value, it is not going to give the 0, it's going to give approximately like 0.2. Now the neuron will not going to deactivate because we have some value. So we don't have 0, we had some value. So that is the thing, we will use the leaky ReLU function. This will help the neuron to run for the next layer. Okay, so that is the thing this activation function will use. It will add some complexity to the model to understand the things. Okay, so after generating image, it is going to return that model. Okay, it is going to return that. So I'm just creating def another function to build discriminator. Okay, it is already suggesting me a dense layer, like ReLU, same things I'm going to use. And here in the sigmoid, I'm going to specify one activation function. See here, I just got activation. I'm just going to use one activation function, guys. So what is the name of activation function? Anyone? Just let me know what is the activation function we need to use in a binary classification. So what is the activation function we need to use for binary classification? Introduce non-linearity, that's right. So what is the activation function we need to use, guys? Anyone? For binary classification, Anand, just check that. What is the activation function we are going to use for binary classification? So for binary classification, we are going to use one of the activation functions. Generally, we are going to use sigmoid. Okay, what this sigmoid means, it is going to give the range between 0 and 1. So if it is the value is above 0.5, then it is going to give it as a belongs to class 1. If it is below 0.5, then it is going to consider is a class 0. Here class 1 is real and class 0 is fake. Like this it is going to act. Okay, so this is the thing we are going to use in binary classification. Make sure you some of the people good with this, they're going to ask as a question. So what is the difference between sigmoid and softmax? Okay, so I'm just calling these two functions. Okay, so I'm just implementing this. Yes, it's done. So now here I'm just going for next thing. So we are just built a one generator and discriminator models. Okay, now what I'll do, I said no, I'm just using Adam function, which will help the model to reduce the error, right? So for that I'm just using this. I'm going to use cross entropy. Okay, I'm going to use cross entropy. So you can see here the binary classification loss, binary cross entropy. Why we using binary cross entropy means in the discriminator we are going to get the only two values, that is real and fake, right? So that is the thing. So for that cross entropy, I'm just going to use generator optimizer I'm going to use as but in place of this I'm just going to specify so where I need to take, right? So otherwise it is going to raise error. Okay, keras, from keras I need to take optimization, right? Just already took, right? So no need to do this, right? Okay, because I already did this. Okay, because I already specified here, right? So it is going to get from here, so I'm just no need to use that. So here LE is nothing but, guys, so here LE is nothing but learning rate. So what this learning rate will do means learning rate will help the model to understand something. So for example, just we are passing 128 images per batch. For single batch we are passing 128 images means if I pass 12,800 images per batch. So what happens? Get error, right? So we'll get error. So because the model will not accurately perform of processing these many images within the fraction of seconds, it will lose some of the information. It will lose some of the information in that images. So that is the thing. If you say that, so use these images, then it is going to take less images and it will capture huge information. So that is the thing. I'll say learn below 4. So give the less learning rate, so you'll get the accurate results, guys. Okay. So this is the thing is going to happen. Okay. And now just we are going to execute this. So we need to pass some data to a generator. Generator will do some tasks. We need to analyze. So just I'm building that now. I'm just using one function that is at the rate of pf tensorflow dot function. So this is my decorator, guys. So it will help model to is a performing in a way or not. It will help me. So this is a decorator I'm going to use. Means it will allow the model to execute a step-by-step process. Okay. So now I'm creating another function. Okay. Train. This is my train. Okay. Train step. So I need to pass, right? So just we have created models here. So for that we need to pass the data, right? So I'm saying this is my data names was images. Saying that train step, in that I'm just saying that this is my images I will pass. Images I'll pass. This is my what we call it as parameter, right? Or we can say it as argument. So for generator I'll pass, we said right, we use noise. So when you create a one variable, okay, tf dot, I'm going to generate random. Okay, I'm just generating random. Okay, yeah, it's good. I'll go with this, but there is issue. But I'll do just remove this, no need of this. See, noise, I'm just passing the random normal. Normal is the thing that the data is going to be follow the normal distribution. Okay, so I'm just passing 100. Okay, so the batch size, what is the batch size? 128. So I need to check that while passing 128. Okay, for batch. Now what I'll do? So this is my data for generator, right? So is there any we are passing anything like we are passing any image? No, just with this data I need to train. So first I'll train discriminator. It will better. Okay, with TensorFlow, gradient tap. Okay, I'm just using this. Okay. So it looks quite difficult, guys, but it is easy. Okay, once you do this, okay, use disk. Okay, yes. So what it will do, I'll just explain. Okay. Okay, so now, so what this will do means I'll just add generator. So and my generated images, I'm just taking one more variable, guys, here. Okay, generated images. I'm just specifying images equals to, I'm just yeah, it is specifying that. Okay, noise and real and output are discriminator generated images training true and the images is training. So why I'm using here generated images is nothing but we are just passing the information, just we are passing the information to the noisy, right? So just we are took the random numbers and we are passing that numbers. The model will perform the operation. After that, it is going to give the generated images. Okay, it's going to give the generated image. So using these generated images, I'm going to check for this discriminator will check the images, means the real images. It will train. Okay, it will get the real output. It will get the real output. Now discriminator I'll pass the, it already got real output, right? So I'm just passing the generated images. I'm just passing these generated images and it will check that what is the difference between real images and generated images, guys. Okay, I hope this is clear. So I'll get fake output, real output. Now I need to compare that is the real output or the fake output is correct or not. Okay, real output. Okay, So I'll just use loss. It's better. I'll use cross entropy to validate that. Okay, cross entropy as TS like a real output we are passing, and it will check with the real output. Next, will cross entropy will check the zeros of the like fake output and the fake input, and it will compare. Okay, and it will compare. Just it will compare. Okay, it will give the discriminator loss. Now it will going to give the discriminator loss. This is how the discriminator loss is going to calculate it. Okay, T of TensorFlow zeros means that is going to create a one matrix. In that it is going to place all zeros. Okay, so this is how it is going to work. Okay, this is how it is going to work. Now what we need to do after finally getting that discriminator loss, we need to reduce that loss, right? So what we need to do, we need to reduce the loss, right? So for that reducing loss, we are going to use this gradient descent. Okay, the gradient descent, I'm going to use this, means gradient des. Okay, one more variable. Okay, just here suggesting, you can see that. Okay, dot. Okay, gradient disk class. So what is the discriminator loss we are passing? And discriminator, so here it is discriminator and trainable variables. Okay, let me do this. Yeah, so discriminator and dot trainable variables. Okay, this is the thing. And next, see here optimizer, we're applying the optimizer as a gradient. So what is optimizer? Adam, right? So Adam optimizer, so what it will do, it will try to reduce the value. It will try to reduce the value in the disk. So it will help that to reduce, overcome the error. Okay, now saying that discriminator is not there. Okay, fine, just will create. Okay, okay, next thing, just will go with this next thing. So what happened, just it is going to do, and again, so we got we tried to decrease the discriminator loss, right? So what about then this generator loss? So we need to focus on that, right? So for that, just the discriminator loss, what we'll do, again we'll check, we'll create one more tab, and here what happened, generator will take the noisy data and it will generate the images, and we'll pass for that images for the discriminator will fake out the output. So what are the output you're going to get? And next, finally, we are going to get the two things like fake and output real things. Okay, fake and real. I'm just going to entropy, yeah, entropy loss. So we are passing the fake output and the fake output. So it is going to give the cross entropy. So here you can see that generator gradient. So we are applying the same tab as generator loss. So we are applying that. We are going to apply the gradient region optimizer. Optimizer will give the output. So this is the thing is going to happen. Okay. Just let me run this. Okay. So this function, this training step need to do, right? Need to training step need to follow this. Okay, let me do one thing. Because in Python we need to follow indentation, guys. It's a mandatory thing. Without indentation, you're going to get error. Sure. Now we are just returning that return. So two things. One is generator loss and discriminator loss. We are going to get. Okay, we are going to get if train state is unexpected indent. Okay, just a minute. I need to check this. So with TF indented does not match with the outer indentation level. Okay. Because we need to follow, right? Okay. Now we need to give another indentation here. Tab space is fine. I will give 2 tab space. So for this, I will apply complete 2 tab space. So now this we need to match with this. You can see that. So now I need to match with the same thing. I think it. I hope it matched. I need to give the same this as a one and one more indentation. It's better. Okay. We go run this once again. Yeah, here it is. So this is the guys. This is the thing is going to happen here. I hope this is clear, right? So till now we just did training steps. We are passing the data. If what happens if we pass the data? So just we did that. Now we'll pass. We'll check that. We'll store some data and we'll start execution. Okay, you'll get to know. Okay, just have a 5 minutes break and we'll continue. Okay? I hope till is clear. Just have a 5 minutes break. We'll continue furthermore when finish this and we'll see how this generator will generate the images. Okay, is it clear, guys? Okay, guys, let's continue here from here. So now what we need to do, guys, let's continue from here. So till now what we did, just we have defined the training step, and just we created optimization, and also we just created our models. Okay, now I'm just doing that. So while processing, I'll get some images. Means every layer is going to update it. There I'm going to get the images. Okay, just I need to see that images. So for that, what I will do means I'm just going to take one more variable. Okay, so this is my losses. I'll get all the information to store images and as well as losses. I'm just doing this. Disk is nothing discriminator. So generator loss and discriminator loss, it will take here losses. I'm just using this now. So what I'll do, I'll just what are the images it is going to generate, that I need to store somewhere. Okay, so where it will what it will do, I'll just show. I'm using operating system. Make a directory. So this is my directories. Images going to be stored here. Okay, exit okay equals to true. Okay, next I'm just defining that generate and save images. Okay, save images. So just it is going to generate right every time. So that images I'm going to save here. So you'll get to know, guys. Okay, don't worry. Just don't get confused. Okay. So what happening here, you'll get to go know in the next step. Okay. Just I'm using a figure. So what are the figure it need to show? It is a 4 into 4. And just make it as 5 into 5. Or else I need to go with 6 into 6. Let's see. After that, I'll just edit it. Okay, this is not temporary. So after every time it is going to predict, so I'm just going to get the images. Okay, so images I'm just using this. We come off 5, right, equals to +1. Yes. So prediction. So here what happens, so every time the images which we are going to add, so that is going to be in the grayscale format. Okay, so axis is of nothing but it is going to have some boxes. That is, I'm just offing that. So just show me that tlt dot and show that subplot title. Just I'm going to use title as generated images by image epochs. I need epochs. So do you know what is meant by this epoch? Anyone? Do you know what is meant by this approach? Anyone? If you know, just let me know. I think I'm doing right. Dot png. Okay. So what is this? You'll get to know, guys. Okay, don't worry for this. Just a minute. Give me some more time. ELP dot show now. Show. This is show time. ELT dot. Everything is done. Just please close it. Okay. Or else something I missed. I think so. Let me check once. For see, I missed something here. Shape. Okay. This one is okay. Of yeah. Here after off, I didn't specify the subtitle as a coach. Okay. Save figure. Okay. This is I need to make the save figure. Save figure. Okay. Now I need to add subtitle and title layout. Yeah, just make this. Okay. ELT dot subtitle. Okay. So subtitle approach is a number of approaches, and next ELT dot type the layouts. I'm just going to run this. Now we are here for final execution of our model. So why I just created this above cell, just you will get to know here. Okay, just I'm defining my train. So I need to pass data set, right? So data set here I'll pass my approaches, guys. Okay, so here I'll pass my approaches. So I'm specifying here 50 approaches. Okay, so why I'm specifying here itself? Because we are just creating a function, call function. So but I'm specifying here. Why? Anyone? And you see it equals to df dot random normal normal random normal. I think you know this, right? Approach, every approach in range. I'm just reading that. Okay. Image batch in gen loss. And next what we need to do means this loss equals to train step. Okay, guys. So what happened here? So every time it will go for a approach and it will give this information like batch data set, what is the loss and what is the discriminator and generator loss. You will get to know while executing each and every loop. Okay. So I'm using generate to loss. Just I created there, no? The top I just created, right? Dot append. Okay. Append. So this is generator loss. Means every time just adding that information to the in the last list. Okay. And using a numpy, so better it will perform operation fast. So now I'm using this class. This losses append. Okay. So what happens if I use this? Okay. Okay, let me click on that. So it's going to do that. So here I'm just print the status. No need of this. I'm just going to print my status. Print it here. What it need to print means this is your approach number, means every approach it will show. Approach plus one means every time it need to update, right? So I'm just using plus one. Next, I'm just asking Jenna use capital. Wait, okay. Generator loss. Gen loss, discriminator loss, it will go and find. Okay. Shall I need to add? Okay, I will just do one thing. Here, what I will do, just if I add only this, I will get only n number of values. Like I will get the continuous after decimal, I will get continuous. So I'll say that only I need four decimal points after that. 4 is fine for me. Okay. Now, so if no need this 15%, we can manage directly with the seed. Okay. Generated and saved images, generate plus approach plus seed. Okay. So this is, I'm just created my own. Okay. For a decimal lateral. Okay. This is right. I hope the key thing is clear. Yes. So just we have created our data sets. Is it clear, guys? So what happening here, you get to know. I'm just calling this function, guys. Okay. Define just created def no. So I'm just calling that function. Right. So I need to pass my data set. So I just give my data set where I give it, just in the top you can see, right, the name of data set I created. So I'm passing that data set here, and just I need to specify approaches. Okay, I'm just giving the approaches. Approaches was I'm just taking 50 approaches. Okay, I'm just running that. Name generator not defined. Okay, let me check that. Where is the error? Let me check that. Is it okay? Generator. It's now okay. Just on every cell. There, just I missed the indentation, right? Okay, so that is the thing we'll get an error. Now you can see, you can observe here. I just overcome the error. So in the previous, you have seen that marks. Right now is not there. So what happening here means, just let the model run. Okay. So I just took that every image need to store, right? So this is how it is going to store. And so what is it happens, this data set is going to pass here. Okay, it will pass by layer, and it will do the process, and after processing it will run here. It will check that what are the images it has been generated, because we called here again generator and pass noise and training, right? So it will do the process, and it will give the image, what are the image it is going to generate, and discriminator will check that. Okay, we'll get the loss, and loss will try to reduce by the gradient. Adam will try to reduce the loss, and it will perform the operation. This loss we are going to get here. So after doing this process, it will save that complete image, and it will give like this to us. Just a minute, taking time. So it's going to print the image. So what are the images we saved? here we said no, the image size, and it is in a grayscale format. Okay, so it's going to print that complete image here, means which has model has been generated using this noise. This noise, the model has been generated, right? So that using this noise seed, it is going to give the information for us. Okay, just a minute. Okay. I need to update for T4, I think. Okay, don't worry, I'll share. Okay, okay, sorry for that. Okay, I'll just explain it once again. Don't worry. Okay, it's taking much time. Okay, I'll do one thing. I'll change my this execution. Okay, I'll go here. Change my run type to TP. So here till now it is running on CPU. I just change it to TP and I will save it, and I'll try to. It's connecting. Wait for 1 minute. This connect, yeah, we got the thing. So just it has been connected. So we need to run each and every cell. I'll hit on run on. So it is running first cell TP. Okay. So while running, check with the collab with internet connection also. That is also a mandatory thing. So it was done. So done. So you can check every cell is running very fast, right? So now we are here. Started execution time. You can check the number of seconds. It's taking time. Okay. We'll wait for further more. So when it is get executed, so you'll get to know all the clarity of that what we did here. Okay. I think there was issue with my internet. I think that one's really going to be the very fast, but now it is taking too much time. Change the internet. Just a minute, guys. I'm just changing my internet connection. Guys, am I audible? Just confirm that. Okay. Let me check this once. Turn all again. So here I just changed my TP T4, but it's still running. Generate and save images. Yes. but taking too much time. Why? I don't know that. Generally, it's going to take much less time, but now it is taking too much time. If before everything is connected, but there are no person background image. Sorry, almost as a file or directory. So plain data set approach, okay, in the line pieces. Generated images. Just let me check this. The file has generated images. Images. Okay, just get image right. So like this image. Okay. I'll make that images. Image approach. Okay. Just let me explain this once again. Okay, I'll do one thing or else. It is taking too much time. See guys here, it's taking too much time. Just let me do one thing. What is the issue? Just let me check that. Just give me a minute, guys. Just I'm just resolving that error. Okay. Sorry guys, just thing has happened here. Yeah, you can see that now. You can are you able to see the screen? Is it visible? So the small mistake is done just here. This has been rectified. See here, guys. You can observe here. So what we did here, just we passed the noise, right? First we send the seed as noise. So that using the noise, can you observe any numbers in approach one? Approach is nothing but step-by-step process. So every approach is going to carry 128 images, means batches, different batches. So you can see generated loss 2.79 of generator. So first we are expecting generator loss, and that after you can check the what is the discriminator loss. So this is approach one. So that is the thing we wrote here, and see here. So what happened, just we are just change the image size here, 5 into 5, right? So this is a 5 into 5. So can you observe anything here? No, it's not possible because it was too clumsy. So what we will do, just we'll go for the next approach. See, every approach the generator is trying to generate something. Every approach the generator is trying to generate something. See, in the third approach, fourth approach. So every updating every approach. So a number of approaches we are just calling that. The approaches is nothing but the running the n number of times the data set. It is going to run complete data set in the 50 times. Okay. So you can observe here. It is going with these many approaches. So it will go till 50. So here I took the 50, right? So if in default case, we are not able to pass any approaches, means it will consider 50. If we pass that 70, it will take the 70. Okay, so that is the thing I just kept here 50. We haven't trained any generator, just we pass the real images to only discriminator. Okay, so the generator has been generating this, it's using the noisy data. So you can see that we have passed a number of times with the noisy data only, right? So here in the from top, you can see that we are passing a random noise data, and here while training also we have passed only random noise, right? So this is how the model will understand and will train the, it will generate the new images. So we'll go for 50 image, the 15th image we'll get to know. 50 approach we'll get to know how it is trying to generate. So you can observe every image. So that is why that I have saved in the previous, I said no, that we are saving some images. So these are the things we are saving there, and we are saving the loss. I just created two variables. One is generator loss and discriminator. This is the loss it is going to. So the main goal is to we need to try to reduce the loss as much as possible. We need to try to reduce the loss. So you can make it as 70, 100 approaches based on your output. So if you are getting the desired expected output, so you need to stop. Otherwise, it may be overfit also. Okay. So this is the final output. So what we are expecting, we are expected more, but we got only the less. So what I'll do, I'll change the number of approaches. I'll change the image, different passing images. Like this, I will recreate that. We'll update. We'll fine tune it the model, and we'll get the best results, guys. Okay. I'll just make it as from. I'll increase slowly. Okay. I'll just make it as 75 once. I'll check that is it okay or not. So it started again, it will update again. So it will start from runtime disconnected. Okay. Let me check that. Still it is running. Okay. So it is running. So you can see it will go for 75 approaches. Okay. So now we'll check the final output. We'll check the final output we are going to get or not. So, okay. So now what I'll check the final evaluation. Okay, just I'll check the final evaluation of these numbers. Okay, what is the final image we are going to get? Okay, just what I'll do, just I'll create one def function. Okay, I will evaluate. While running, guys, check with that all libraries you have installed or not. Okay, I'm going to use evaluate discriminator. This is my function. Okay, Okay, randomized batch size I will pass. Okay, normal distribution. Training is just okay. What are the things we give? Just make it as a batch size. Okay. So this is the batch size we are going to pass. So here we are going to say that real images. Real images. Let me do real images equals to next pair. Okay, just need to add. Okay, so just we are going to get the predicted and accuracy of the model. Okay? Just by passing this, we'll get the predicted output. I'll just predict. Okay, this is real and the fake. So we need to get what is a real and fake. Okay. So you can see every time. So in the previous and now you can check that the output, what are the output we are getting, right? So now the images were slightly good, right? Now I'll need to add accuracy. Okay. To reduce the mean, I'll just use this. Print real accuracy and the fake accuracy. Yeah, if we reach 75 approaches, let's check that. Yeah, 70 approach and we are in 75. So this is the output. So now we will get. So you can check that what is the loss and so it is 1.2. Let's visualize that. We'll get more clarity on this. Just will plot this figure. We'll get more clarity, guys. Okay. Plot figure PLT dot plot gen loss of generator, discriminator loss, approaches loss. Okay. And but approaches loss and title. So it means titles. Well, I'll just add title PLT. PLT. Why I'm using PLT? Title. Okay. I'm just using training loss. It will show us in a grid format. You can expect in grid format or else not. It's a wish. You can just run this. You can see it, right? So what is the loss is quite slightly decreasing when you are using increasing approaches. That loss is slightly decreasing. So generator loss and discriminator loss you can observe here, right? So when it has been started, it was nearly 2.5 and the generator loss. So when it is came here, the both discriminator generator near same point, right? So this is how you can visualize about your model, guys. Okay. Just let's display the final images once. We'll display the final images and the final output. Okay, just a minute, wait. So I hope clear till here. Generated images. Okay, just I'm not going to pass anything. Random seed numbers, everything is done. So what I'll do, just I'll remove this noise equals to df tensorflow dot random noise. Okay, and generated images training false. So it will take and calculate and it will going to give the final output, guys, for us. Okay, final image. Okay, EMT figure size, right? upper I in range of 25 means I'm just using that. Means I specified batch size as 25 now, so that is the thing. Plot it. Plot as subplot. So image will show on this grayscale, and the is off, grid is off. Just I'll show that how on and off also. I need to make that one more tab space. ELT dot. So plot then generated images and layout and show. Okay. So I need to call this function. Just I'll go there. This display generated images. So it will run the complete loop and it will give the final output. So this is how the model has been generated. I'll just make it as one. Okay. So this is a grid. Okay, you can see that 0 to 25. So 25 25 the image size. So this is how it is going to be generated. This is a final output, guys. Okay. So from complete all it has been generated, and based on that it has been given a final output for us. Okay. So as I think, is it clear? And we can evaluate the discriminator. All else we can do a number of things. Okay. Hope, I think, is it clear? Okay, I'll share it. Don't worry. Okay. So is it okay? Are you able to understand today's session? So do you have any queries? So this is how generator will generally going to work, guys. So generator is going to try to generate, and the discriminator will give the it is the images are real or fake. Based on that, finally it is going to give one generated image. Sure, don't worry, I will share it. So try to finish the labs, guys, as soon as possible. I'll check and we'll let you know so about the credits as soon as possible. I will try to provide the credits soon. Okay, don't worry. So in the next session I will inform you about the things, all the things. How was today's session, guys? We know. Okay, sorry for that. I hope try to understand, rewatch it. Okay, just due to that working slow that. So that is the thing. So I just moved very fast. Okay, don't worry. Just try to revise the first for this is first, right? So how this generative AI in the generative model it is going to work, it is difficult to understand. But I hope that the thing what I explained was clear. If not, try once. I will just explain it once again if you want. Okay. So in the next session, we will discuss, guys, how till now we discussed how this image is going to generate. Now, next we'll see that how generally from text to image, how this text to image model is going to work. Okay, we'll see how this text to image model is going to work. So we will use some pre-trained model, means already which has been gave from the Google as well as Hugging Face, right? So there is a lot of models we'll explore that and we'll understand more easily. Okay, don't worry about that. Okay. Yeah. Okay. I will inform. Okay. So that was issue from cloud, guys. So if you are facing issue with the Vertex AI, so it was issue from the cloud. Okay, don't worry. So try to raise a mail. So they're going to rectify as soon as possible. Okay. I hope things is clear for today. So we'll meet in the next session. So try to learn more. Okay. So try to finish the labs. So we'll discuss. So if you have any doubts or queries, just please feel free to ask. Okay. So we are here to clarify that. No, not you need not to send the mail for SmartBridge. You need to send the mail for Google. Okay. So in the top of right corner, you're going to have the help section. There you're going to find the mail option. So please mail to them. So they're going to rectify with your screenshot. Okay. I'll share it in the group, guys. Okay. I'll link up the code. I'll share it in the group. So you haven't joined the Telegram group. Just I'll share the link. Just a minute. Yeah, I will share the code. Don't worry. So it was too complete. What we did means generally just we have imported libraries, guys, first. Okay. So after importing libraries, just I have created one class, two methods. One is generator for generator using different layers. So what these layers will do means it will analyze the image. Okay, complete image. It will analyze. It will help the model to understand. Okay. So there, if you go with the CNN, you will get the more clarity about these layers. Like dense layer, we have flattened layers, and we have like ReLU activation functions. These are the concepts of deep learning. Go through it once. Okay, you'll get the clarity. After creating generator and discriminator with the different layers using sequential, we have just passed the training data. Okay, just we have passed the training data. After passing training data, we are going to get some loss, right? So after passing the training data for generator, so what it will do? Generator will use noisy data and it will generate some images, and it will compare by discriminator. Discriminator will check that is that real images or fake images. So it's going to give us some loss. So finally, what we'll say that we'll get the discriminator loss. Means adding the two different losses like the discriminator and these loss. Just I'll share that. I'll go through it code once again. Okay, let's get clarity, more clarity. Okay, what happens here? So So what happens here means in this training loss, so generator will generate the images, and using this discriminator, now we are passing the two discriminator, means we are passing here, right? Okay, here in the discriminator. So it will pass the images, so means real images, data set, okay? And will say the training true, means please train, okay? Train by yourself. So it will train and it will give the real output, okay? It will give some output. So passing this output, real output for the discriminator, generated images, already generator has been generated, right? So after that, we'll pass these generated images to here, and we'll explore, like we'll say that it will find the difference between real and fake output, okay? So we'll get the real loss, will cross entropy. Cross entropy is nothing but it is the entropy which will give the differentiate between. So loss, no, we need to find the loss. How much loss will, how much difference we got, we need to know. So this cross entropy will help you to get the loss, guys. Okay. And next we'll say for the fake image also, it's going to give the loss. So after we'll find the real loss and fake loss, we'll get the complete discriminator loss. Now we are clear with the discriminator loss. In the same, we'll apply to reduce this loss, we will apply the gradient descent optimizer. Okay, so here we have performed the trainer variables and just we have said that add gradient descent. So where we are adding, so this is Adam, already I said, right? We'll add this. So what happens after adding this? So we'll get the discriminator, we'll try to reduce the loss. Same for generator also, we need to try to reduce the loss now. So we are going to do that. So using generator noise and training, we'll get the generated images, and noise data will train, generator will generate the images, discriminator will train on that, and it will give the loss. Okay, so now here we are going to get the loss and we'll try to reduce same as applying the same Adam. Okay, so it finally we are going to get the complete loss of generator loss as well as discriminator loss. So this loss will help the model to understand more, guys. Means every time we'll give the some difference. For example, your friend brought something items, we'll check the difference between and we'll say that this is a difference between you and your friend. Okay, so that difference is going to be try to overcome. Means like for example, there is a marks between two friends, we'll say he got 98, you got 90. So what is the difference? 8% is different. So we'll update to him. So what we'll try to overcome in the next exam. So in that way, we'll get this loss and we'll say the model to overcome. So the model will train on and it will try to overcome that loss. Okay. Now this is the figures. Just I said no, these are the figures I need to store. So that is the thing. What I did, just I took some loop here. I just took some loop here, okay, which is going to store my information, which is going to store which has been created. This is my file, okay. It is a file which I am going to create as my directory. In that, there's a file name, so it is going to store the information. Okay, these images are going to store. The image size is 5 into 5, and it is going to work on protection. Means like it is going to show that. So grayscale. So it's going to give the complete like box. It's not going to give the single image. So if I do this, it is going to give complete 9 to 10 images in one place in a grayscale format. Okay, access I already said, just I on access, and the approaches, you know that approaches what you will do. And this save image, it is going to save the name and image. Means see, this is a epoch 1, so this is a image. Epoch 2, this is an image. So with that name, it will save that images here. Okay, so this is going to work. Coming to this, you already know that. Just what we will do, we'll add the loss. So we'll append the loss every time. We are going to append this loss, right? So this loss every time we are appending. So this is loss is going to update it every time. So for single approach, it will update. Means it will run complete code again, every time. So every approach it will learn. Means every time it will learn complete data. Okay. So this all will run and it will give the output for us. I hope this was clear. Okay. Not go with once again. Try to finish as soon as possible, guys. We'll try to do. Okay, if you finish as soon as possible, you are going to get the certificate from Google. Okay, so that is in your hands. So make it fast. Don't not possible. Please try to finish. Okay. If there any issue with that, without except cloud issues, if you have any issues, that let me know. Okay. Okay. Have a nice day. We'll see you soon. Okay. We'll meet in the next session. Thank you everyone. Thanks a lot. Bye guys. I'm just winding the session. So okay, if you have any queries, just discuss in the Telegram group as well as in the next session. Okay, so in the next session we'll see the image generation. Okay, how it is going to do, how we are going to get the API key, how this is generative AI going to work. Okay, bye everyone, take care, bye.